So welcome everybody to this talk today on fabricating continuous improvement with Kubernetes and Jenkins pipeline. So software is eating the world. In the old days, software used to be about reducing cost. It used to be about avoiding dual entry of data and so forth. Increasingly now, the software is all about making competitive business value, right? People talk about businesses being Uberized, right? Every business is now a software company. Do you remember Cisco? I used to think of them as a networking company. Now they're a software company. Even car manufacturers are now really software companies. Pretty much every business is really about building software. And increasingly, it's not just about building software. It's about building software quickly. It's about going fast, right? The quicker you can build some software and go live and give it to your users, the more you can iterate, the better you are at delivering software, right? Software is really hard, right? It's really big and it's complicated. The old waterfall model was the worst possible way, right? You'd spend a year writing feet of documentation about the spec, then you'd write a year figuring out what the code was, then a year testing it, then a year releasing it. By the time 4 years have gone by, most of the people have left who originally wanted the system, and they deliver something that usually has no real business value anymore. So we want to do everything the opposite way. We want to go fast, write some code, and get it into production immediately, and then keep iterating as fast as you can, right? The quicker we can go, the more feedback loops we get, the better our software becomes. So increasingly what we want to do is deliver business value as quick as we can. And what we all kind of want is continuous delivery of containerized microservices, which is a bit of a mouthful. So what that basically means is we want to go fast with microservices, which I'll explain in a minute, and we want to containerize them because that's the quickest, easiest way of getting them into production fast. Now, there's a couple of different memes and buzzwords at the minute, microservices and DevOps, and they're kind of different sides of a similar coin. The basic way of going fast with software is rather than having a big monolith, which is huge, with a huge team that takes a very long time to release, you split your code into small microservices. The key point is each microservice has its own independent release cycle. This is the key thing, right? If you release all the microservices together, then really that's just a monolith, right? The idea is each microservice has its own release cycle. This is key. So part of microservices is you split the software into pieces, release them independently. The other part of the thing is a social. Rather than having one big team, which usually gets siloed into testing and QA and development and support and operations, you have one team that owns that microservice for the entire lifetime of the microservice. So one team is usually a cross-functional team that has design and testing and development and support, and that one team takes care of the entire life cycle of the microservice. So this is kind of a way of hacking the mythical man month, right? If you have a big team and you want to go faster, you add more people, you go slower, right? Microservices is a hack to get around this. Rather than adding more people to a team, you add more teams. Each microservice team can then go really, really fast, right? You can iterate and go really, really quick. And one of the key points, though, is moving from a monolith into lots of microservices, you're going to need to automate everything, right? Back in the good old days of waterfall, you do a release every 4 years, right? So it didn't matter if that was totally manual, because you only do it once every 4 years. If you have hundreds or thousands of microservices which are releasing every hour, you're going to need to automate everything, or you're going to spend all of your time just releasing, right? So the basic thing is we need microservices, we need to containerize them, and we need to automate everything to go fast, right? So to go fast, we need to automate everything. So how do we do it? So this is what we really should all be aiming for. We want continuous improvement. We want continuous assessment, continuous delivery, continuous integration. We want to be continually doing all of these things and getting feedback loops. The more times we do it, the better we get at it. The more feedback we get, the more we can iterate and get better and better and better. And these cycles just hopefully should be getting quicker and quicker and quicker. There's a really good survey, the DevOps survey, I recommend you read. And it's got a really interesting set of stats about really high-performing companies go faster and faster and faster with time and do more and more releases per day. I think Amazon is now 1 every 7 seconds or something, right? They go crazy fast and release all the time. The low performers tend to do less and less releases over time, right? So what we really want to be doing is we all want to be high performers. We want to go fast and do lots of releases, right? Because then we all get better. So that's all very well. So what we really need is a microservices platform. We need a way of automating all of this thing, right? So we can create projects, have them built, have them deployed, have them tested, and iterate and release quickly. So I'd like to introduce you to an open source project which we work on called Fabricate, which is a microservices platform. So what is a microservices platform? These are the features. Oh, I should mention, It's Apache license. It's open source. Well, of course it's open source because we're at DevNation. But yes, it's open source. It's Apache license. These are its basic features. It's got features to automate your entire life cycle of your project. So it's got wizards to help you create new projects. For example, from Maven archetypes or templates. You can just customize the Maven archetype and generate a new project. Pick any kind of project, whether it's Node.js, Golang, any kind of Java stuff, Spring Boot, Wildfly Swarm, yada, yada, yada. Build immutable container images. I'll talk a little bit about Docker later in the talk. Then we do releasing. Using multiple environments, you typically want to use a test environment to do integration tests and system tests and load tests and soak tests and all that kind of stuff. When all of your testing is done and you're happy, either automatically or manually approve it to then production. So you have the complete end-to-end pipeline automated. Management is a key thing. Once you start using lots of microservices, it's quite hard to keeping track of what's going on, right? Quite a lot of companies have hundreds or thousands of microservices, and each one of them is releasing all the time. You need centralized logging and metrics and alerting. Otherwise, you have no clue what's going on. So that's a pretty key point. Finally, we need feedback. We need lots of dashboards and metrics to know which builds are working, which builds are going too slow, which microservices are taking too long to get human approval to go to production, and so on and so forth. So to get that feedback loop going, we need lots of metrics. So the quick overview of Fabricate is Fabricate is implemented in microservices. It all runs on top of Kubernetes or OpenShift. And it's microservices all the way down. Here's a quick screenshot of some of the microservices in Fabricate. We have lots and lots of things. Fabricate kind of started, we're really building an iPaaS, an integration platform as a service, which if you think camel in the clouds, right? Camel in the clouds is kind of what we're doing. We found that we needed all of these things just to actually do camel in the clouds. There's lots and lots of them. For example, Gerrit for human approval and code reviews. We've got microservices that capture Git metrics and put them in Elasticsearch and yada, yada, yada. So we have tons of microservices in Fabricate. So let's fabricate microservices. I'm now going to pass you over to James, who's going to do a quick demo. Well, quite a long demo, actually, probably. Which is going to show you how to start from nothing. Just log into Google Container Engine and build Fabricate. Go for it.
Cheers. Yeah, so hi, I'm the other James. I've cheated slightly, so I've got a pre-recorded demo here. It was recorded on Monday. The only reason is because I've sped up a couple of points, but I can wholeheartedly say the actual demo that I recorded on Monday took 29 minutes. So if you see what we're going to play now, I'd highly encourage anybody to go away and just actually do this. So with that, I'm just going to hit play and kind of talk you through, try and go slowly. There's a lot of things here, but grab us afterwards to ask some questions if I skip over something, please. All right. So this is Google Container Engine. This is where we're going to create, with a couple of clicks, a cluster with Kubernetes on Google's cloud. So if I start off with this, I've already logged in. You can see there's a handsome guy up the top right-hand corner. That's me logged in. So once I click the View Console, it takes me through to my Google Cloud Platform dashboard. So from here, we can create a cluster. This is going to be a 3-node cluster, and it's going to be our Kubernetes cluster that we can actually then deploy and start running some applications on the Fabricate microservices platform. Here, we're just going to click 4 CPUs, 15 gig of memory each. That's excessive for what we're actually using here, but just thought try and be a bit more real life. A lot of demos we see are just one single node. We want to show that we're using a full cluster here. So we've just clicked, with a couple of clicks, created an entire Kubernetes cluster. To be honest, frankly, this blows my mind in itself. We haven't really got started yet. You can see slightly I've sped up there. I think it takes about 5 minutes for it all to finish. Once we have our cluster, we need to take a couple of things out, bits of information, so that we can connect to it. And we still want to start interacting with the platform. So we've got an endpoint here. This is our Kubernetes API server. I've got a script here. We use something called kubectl. That helps us interact locally from our laptop or from our desktops, interact with the cloud platform. So we can copy our API server URL, IP, add in our credentials, and we can run this script in the terminal, and that connects us to the cloud. So we can start interacting with it. We run this in the terminal, and we can see now at the bottom here, we've got our 3 nodes that we've just created, all, again, within just a few minutes. So now we've got everything set up. It's all there, installed. We can now start layering on the Fabricate platform. So default applications. We're going to use something called Go Fabricate. It's a binary we get from GitHub. We can just type Go Fabricate deploy. And because we've already authenticated with the cloud platform, with Kubernetes, it already knows where we're going to actually start deploying these applications. As a default, we've installed and set up some of the basic applications that we need to build and release software. We've also adding in a load of application templates into the platform so that we can run those one-click installs that James was showing from the screenshot before. So once we've run this, we're talking to the Kubernetes API server, we're talking to our cloud, to our Kubernetes cluster, and we're telling it to start deploying some applications. We can get pods. James is going to explain a little bit more about this afterwards, the terminology, but we can actually see what's now running and what's actually being deployed. Kubernetes is going off to Docker Hub to pull a load of Docker images down, and we can see the Fabricate console is already running. Some of the other pods that are there, Jenkins and Gogs, we'll have a look at in a second. Because our console is running, we can now open up our browser using something called the service proxy with Kubernetes. We use our same credentials, and we can log in to a console. This is the Fabricate console that is running on top of Kubernetes and helps us work as developers and manage and work with our new applications. So this is the Fabricate console. On the left-hand side here, we can see the Kubernetes resources. More about that later. But it helps us be able to, from a nice UI, UX experience, be able to interact and start working with the platform. You can see here now on the overview page, we've got the other applications have already been started. We've got Gogs for Git hosting. People are familiar with Jenkins, help us build our applications with our continuous delivery pipelines. We've also got a Docker registry, so we can stage Docker images. This is our pods perspective. So this is actually how we can go in and have a look at the containers that are running. We can look at the logs. We can even SSH into the containers as well. A little bit more on that later. Just want you to show that we've actually now, with just one command, we're now running everything that we need to be able to build software. That takes a couple of minutes to pull down those Docker images. On the right-hand side, it's just missing from the top of the screen. We have a run menu. I think we go. Just to see as well, Fabricate actually has a facade over a lot of these applications, like the Gogs hosting and Jenkins. But you can also, of course, link through to the running Jenkins instance. I don't know if you saw there, that was an empty Jenkins instance. No build jobs were created. What we're going to eventually do is start automating the creation of a lot of projects and taking out those manual tasks that take us so long. We go to the run menu. Now that we have everything to build our software, that's out of the box. We're going to use a one-click application. This is all the default ones we have. Let's Chat, Manage IQ. We've got logging and metrics. We've got them bundled up into a single one-click of management because we want to know what's happening within the platform. James mentioned about centralized logs and centralized metrics. With this one click, we can actually run instances of Elasticsearch and Kibana for our centralized logs, as well as Prometheus and Grafana for our centralized metrics. By clicking this one button, we're wiring everything together, taking out all those manual efforts. The key is we want to automate as much as possible, so it makes it as easy as possible for people to start adding value and creating value faster. So I think I speed that up again, but after 51 seconds, there we go, we've got everything running. If we go back up, I think, to our link, we now have a new option. We have Grafana. This comes now out of the box with some pre-built dashboards. We can see our Kubernetes cluster. We've got some camel routes. We've got some other dashboards that we've got out of the box that people can start making use of. So you can actually see what's going on within the cluster. Here you can see we've got the memory consumption being used. We don't dive too much into this, but this is our 3 clusters that we've got. It gives us great insight to actually seeing what's the health of our application, of our cluster and applications. We've also got a Nexus being a bit slower being started for any Java applications, so we can cache the Java dependencies. And this is Kibana starting up. Kibana is a powerful UI to be able to search for our centralized logs and be able to interact with our Elasticsearch instance. Again, similar to the Grafana, this comes out, the Fabricate images applications come with some pre-built dashboards that we can now use our centralized logs. So we can actually see in a nice format, we can actually search within our logs, within the entire cluster. So we've got, again, another powerful way, something that you absolutely need, especially if you're going into the new microservices world, to be able to search across different environments and different applications. So now we have everything to be able to build and manage, we can go ahead and start building some applications. Using the Fabricate console, we have a wizard, project wizard. These are the applications that we have. We actually, nice quick starts to get people going quickly. People think, probably a bit of a misconception about Fabricate because where it was born from, but we're not just focused around Java. We want anything that runs in a Docker image that can be built, we want to be able to run. So we had other options there of Python, Django, Golang. We've actually created a integration project, which probably no surprises, is going to be based on camels. That's a Java project. As soon as we've selected this, we get taken to our next screen, where we get to choose our pipeline. This is our Jenkins 2 pipeline. So Jenkins 2 uses Jenkins pipeline, which is the backbone for continuous delivery. It's their new focus, as opposed to continuous integration. They're focused towards continuous delivery. So we select our pipeline that we want. These are totally customizable. These are just the default library that we've got, extendable by yourself, but they're sensible to be able to stage, approve, and promote our application. So once we've clicked Next, we've now created the project. Under the hood, the wizard is now interacting with Gogs, it's interacting with Jenkins, wiring them all up together with webhooks, taking out all those manual activities that, frankly, teams are actually paid to do right now. We want to remove all of those activities. Under the hood now, Jenkins is triggered because it's got a new project. It's now, Jenkins itself is talking back to the Kubernetes master and is requesting a new agent to be able to build our application. So it's a very scalable way of using Jenkins as well. The more demand, the more jobs are needed, the more jobs are requested from Kubernetes, and more build pods are run. We can see now we've got our pipeline, and just at the bottom here, we've got our logs. These are the output from our Jenkins build pod. So we can see the first time this is run, because it was an empty nexus, we didn't have any of these dependencies. So it takes a little bit longer, but they'll be cached so subsequent builds will be run faster. So that's our first application. It's a Java application that's going on. On the left-hand side, you can see our environments. Pre-configured, we've got a testing stage in production, but we can modify this. Again, this is just some out-of-the-box defaults that we've set up. We've also got our apps view, so we can actually have multiple apps. We're going to be looking at tens, hundreds, thousands of applications, microservices. This is the Git URL that you might put into your IDE or from your terminal, Git clone. So we can now also start interacting with our new project. Just for fun, we're going to create a Node.js application as well. You can see some of the other ones. We've got Swift, Spring Boot, Function. If anybody wants to know about Function, I'm sure James will happily speak about Function afterwards. One of the interesting things is, here, even though it's a different language, it's Node.js, we're using the same approach, a common approach to actually building, using a common Jenkins pipeline to be able to build, stage, approve, and promote. So we want to have consistency in the way we're working. It doesn't matter what the languages are, but within our organizations, our different teams want to have a consistent way of working. It helps to be able to interact and move around within organizations, using the best languages for the right purpose, for the job, to do the job. Heading back over to the integration project, we have a nice little wiki, allows us to dive into the project that we've just created. We can actually go and edit this. The Jenkins file, which is the backbone of the pipeline, this actually lives with the code. So it's actually copied into the project and lives with the source code. And that describes its CD pipeline. The integration project we selected is actually a Spring Boot application. We can see a Spring Boot here. And we also know, because the console that's running, it's detected it's a camel project. So we have a nice little camel editor here. So we have the entire ecosystem of camel, of all the integration points. We can now add in extra components and routes, enterprise integration patterns, being able to extend our application. Making changes, again, committing and changing the source code under the hood and committing that back into version control. Lost a couple of our icons there. So back up to the top, that's been running for 1 minute 44. Like I said, it's going to be a little bit slow the first time. It's a Java application. I think I speed this on a little bit now. Just a bit. So this is going to do a canary release. This is going to do a Maven release. It's also going to build our Docker image using Fabricate tooling. It's also going to use Fabricate tooling to generate the Kubernetes resources and able to tell Kubernetes how to run the application. So we're generating all of this. We can see we've now just done the deployments. We've done some integration testing. We've deployed into staging. It's blue at the moment. It's just gone green. That means it's ready. So we've actually deployed our application, and it's being automatically deployed into our staging environment. We can see the version there. It's demo int, and we've got the version 101. We've got some nice, because this is our dashboard, we've got some nice links to other areas. This is our content repository, because we've deployed our Maven site to content repository. Over time, we want to be deploy more things like automated release notes. Basically, anything that helps us, gives us more information about making well-educated approval decisions. We want that to be living with that project. We've also got a metrics link now. Going back to our centralized metrics, we can now see the performance of our application running in our staging environment. We don't want to be wildly just actually approving these releases. We want to ensure that our memory consumption, our CPU, is as we'd expect. We can see here we've got our camel processing time, our camel exchanges completed at the bottom here for the last 5 minutes. Again, these are just default dashboards, but we're going to be expanding these over time, as well as you may well want to be customizing these. So from here now, from the dashboard, we can actually go in and have a look at our environment. You can see our demo int. We've also got our Node.js. Our Node.js app has actually been built already. We can, from here, look at our logs of the app running. And because it's a Java project, we use JMX and Jalokia. We can dive into the application, and we can see at real time our camel exchange is going through. So if we look at the route that was created, and on the left-hand side, we've got 14 real-time counting up, being incremented. A great way, again, you need this insight to be able to see how your applications, how your microservices are working. Head back up to the dashboard. We want to have a look at our centralized logs. These centralized logs is going to be for every single environment. So because we've got some of this powerful searching, we can just add in a search comment at the top. I think we add in int for our int project, for our integration project. And down the bottom here, you'll see our Spring Boot application. So it's found the logs for our Spring Boot application. And again, that would be, because it's nicely parsed, we can actually then filter on different environments as well, just staging or just production. So we have everything that we're pleased. We're going to proceed, and that's going to do a deployment into our production environment. Again, you can see it's gone gray. It should go green, sorry, blue, and then green. If we head back shortly now to our Node.js. Now, our Node.js quick start actually has a web endpoint that we can hit. And this is our very simple Node.js application. We can see it's just a hello from the Fabricate Node.js example. Again, we want to have these links. This is our dashboard. We want to make it real easy to be able to interact with our applications. We don't want to be having to go back to different Jenkins or GOGs, logging into different areas. We want to be able to have everything we need to interact with that project right here from this dashboard. Just for full life cycle, we go ahead and make a change using the editor. You could do this from your IDE once you clone the project. Let's just change this. Once we save this, this is actually going to make the commit into the version control, into GOGs. Jenkins, because it's got all the webhooks set up, is going to realize that there's been a change. It's going to trigger a new build. That's going to trigger our new release, 102, and then automatically run the integration tests and go at the same continuous delivery pipeline. We can see here, actually, this is totally real time, how quick it actually now is, because now it's built everything. All the Docker images, build images now cached. We've got our dashboard where we can see nice donuts. Everyone likes donuts. We want to be able to see the health or how the number of applications. We're expecting this to grow and grow. We want to be able to scale to the demands of people's microservices, the number of applications. So you can see The new app has been built. This is Jenkins has been triggered. It's built our new application, new version, and it's now performing a rolling upgrade. This is a Kubernetes feature of a rolling upgrade to safely bring down the old version and bring up the new version. Slightly slow process. Once that's finished, we'll be able to see the Git version. I don't actually do it in the demo, but you can also click the link to the Git shard, and then you can actually go have a little diff for the projects as well. So you can actually see your changes as well. So we can see we've got a Git shard of EA9 in the one environment, in the staging environment, but not in the production. Hello, San Francisco. Just to finish up now, just to do something slightly different, we expect people are going to have different approval processes. We've just got something basic at the moment. People might use Gerrit, people might have custom approval processes. We can now go over back into our centralized metrics. We want to have a little look at how the health of our environment, our staging environment is. I'm not going to go into it now at the moment. In fact, we've done another blog recently. If anybody's got a keen eye, and if you can see back there, there's a quite substantial difference in the resources being used between the Java and the Node.js application. On the left-hand side is the memory usage, and on the right is the CPU. Java has quite a hefty memory footprint. The point is, we need to know about these things. If we're building these hundreds, thousands of applications, we need to understand what the impact that is going to have. So we can actually then do predictive scheduling of and requesting of resources. So lastly now, we're just going to go back onto our centralized logs. We want to understand and visualize the events that are happening, not just the metrics, not just the health, but also the events, so that we can understand how we can improve. Again, all out of the box, we've got the number of deployments per application. For the last 15 minutes, we can see this is our demo in. Our Node.js application is being deployed 3 times, because we did the last deployment into a staging environment. We've also got, down the bottom here, we've got builds per application. Again, you're talking a huge volume. You need to have this visualization to be able to see your application's health, and also the performance of your teams as well. On the bottom right-hand side, you've got the number of successful. We use this for Fabricate's own release pipelines as well. We use continuous delivery. It's not quite as green on our dashboards, but we need to know that, because that's where we're working towards to improve. We see the logs of environment, and on the far right-hand side, this is the approval wait time per application. This is going to help us understand where there might be bottlenecks. We want to remove as many manual activities as we can, and that might help us identify potential problems or areas we can improve within our organization, within our teams, for those manual processes. And that's it. Just back to this. I'll hand back to James now.
Thanks, James. But great demo. It worked. Okay. So that was an awesome demo, thank you, James. So now I'd just like to talk about the technology that's happening under the covers. Like, what is all that stuff you just saw? Apart from the donuts, like, what's the real stuff underneath the covers? So Fabricate stands on the shoulders of many giants. The main 3 giants, this is a dodgy metaphor already. The main 3 giants we stand on the top of the shoulders of is Docker, Kubernetes, and Jenkins. Docker, you've probably heard all about Docker already at Summit and DevNation. It's pretty much the standard now of how we package software. In the old days, you'd have maybe RPMs or packages or yum install this or that, and you'd have big readmes of how to install stuff. Now you just put stuff in a Docker image and it just runs anywhere, right? So Docker is how we package and run software. Remember, it's all about speed and reproducibility and automation. So by putting things in a Docker image, it makes it trivial for anybody to run it anywhere. Kubernetes, you've maybe heard a little bit about Kubernetes and OpenShift in Summit. It's the platform for running containers at scale. It's how you take a bunch of machines, install Kubernetes on all machines, and then you have a cluster that you can just run containers on. I'll go into a little bit of these in detail in a second. And then finally, Jenkins, like everyone uses Jenkins, right? We've traditionally used Jenkins for continuous integration. Now, everybody, I guess a decade ago, we started to do continuous integration, and now pretty much everybody does that. The future now is for everybody to do continuous delivery and continuous improvement, which is about pipelines, automated testing, integration, staging, and yada, 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 just like the demo. So I'd like to walk through these technologies a little bit more. Docker, one of my favorite things about Docker is the metaphor. When a standard shipping container came out, in the old days, transportation, you used to send, barrels and bags and random boxes and stuff. Then the standard shipping container came out, which meant you could stack things in 2 dimensions. You could put standard trucks and standard cranes to be able to move shipping containers. You had standard tools to open and close the doors, right? It made transportation much easier because you just figured out how to use the shipping container. Docker is a similar kind of thing. Once you figure out how to work with a Docker container, you can work with any software in the box. Right? It doesn't matter if it's Java or Node.js or Go or anything. So Docker is about packaging up processes into a container, which is then easy to run anywhere. Each process is isolated so that you don't get clashes. If ever you try and run, say, Tomcat on your laptop, the first one starts up fine, and then the second one barfs because we're using port 8080. You don't have these issues with Docker because every process has its own virtual network. So every Docker container can listen on port 8080 if it wishes, and Docker takes care of all this port swizzling and virtual file system and all that kind of malarkey. So Docker is a really good way of packaging software and making it easy to run. And this is the command line with Docker to run things. If there's one command line you probably need to learn now, it's this one. If you can do Docker run, then you can run any piece of software. Pretty much every software now is Dockerized. So you do Docker run -IT, which is like a command line thing to do an interactive terminal, and then my user / my service is the Docker name. My user is the username in the Docker registry, and then that's the Docker. If you can type this command in, you can pretty much run anything, like PHP and Node and Ruby and anything like that. If ever you've tried to install NPM packages or Ruby gems, and the first time it works great, and then you try it 6 months later and you have version conflicts and you have to delete everything and start again, it's a nightmare. Running things in Docker is really, really simple. So Docker is awesome. Kubernetes is awesome too. So Kubernetes started about 2 years ago. You probably heard about this already at Summit. Google started the Kubernetes project, and then Red Hat jumped on the bandwagon, and now lots of other companies are part of the Kubernetes community. It's a huge community, really, really active. And Kubernetes is really, it's an awesome project. I love it to bits. It's really about how to run containers at scale. This is the Kubernetes version of that Docker command I just showed you, kubectl, or Google has called it kubectl, which is kind of cute. Kubectl, you get the cuddle when you're using Kubernetes. So kubectl run, then you give it the image name and you say how many replicas to run. And what this does under the covers is it will make sure there will always be 5 replicas, in other words, 5 instances of your container. So you might have, say, 4 machines. You could kill a machine at any point in time or kill a process at any point in time. Kubernetes is constantly watching the system and will ensure there's always 5 instances running. Right? Life's too short for humans to sit there watching software to make sure it keeps running, right? There's no point in getting called in the middle of the night that a server fails, right? You want your cluster to run things for you. If it fails, restart it, for Christ's sake, right? So Kubernetes takes care of all this kind of stuff for us. It's awesome. You say how many replicas to run, and it makes sure it happens. Here's a quick diagram of what Kubernetes kind of looks like. You run a little daemon on every box. You have Docker installed. You have the Kubernetes installed. A little daemon runs in each box. And then you have a highly available master, which you tell it to run 5 instances of something. And it watches the system. And if there's too many running, it kills some. If there's not enough running, it runs more. So it's really, really simple, really. Jenkins, you've probably heard about Jenkins already, I hope. Jenkins 2 came out a couple of months ago and adds a new thing called Jenkins Pipeline. If you've been watching over the last year, it used to be called Jenkins Workflow, which is kind of confusing. So if ever you hear Jenkins Workflow, think that's now Jenkins Pipeline. And Jenkins Pipeline is basically a groovy DSL, go groovy, for declaring your build pipeline, right? How to build things, how to test things, how to stage things, how to promote them, and blah, 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 blah. The metaphor in Jenkins is pipeline as code. In other words, you use programming code, Groovy, to define your pipeline. Typically, your pipeline is going to be running command line tools like Maven, or if you're a Node.js guy, Gulp or Grunt or Make or whatever tools you use, right? Most of the pipeline is going to be running the same things you use anyways to build things, your build tools and whatnot, and that goes in your pipeline. What's kind of interesting is traditionally people used to have a Jenkins server, and in the Jenkins server you define builds by hand, and you'd have these user interfaces where you'd edit all the various flags. These days now you put all of your build in your pipeline in your file called Jenkins file. The Jenkins file is a single groovy DSL, and you check that into your source code. So every project tends to have its pipeline in the source code of the project. There's a Jenkins plugin called, what's that plugin called that detects the Jenkins files? Jenkins, GitHub, something. There's a branch plugin. Anyway, there's a plugin, can't remember what it's called, that you can tell it which GitHub organizations to look at, and it will track every repository and branch in your organization. And whenever you create a branch with a Jenkins file in, it automatically spins up a Jenkins build for it, right? So we can automate the creation of Jenkins builds automatically just from your source code, right? So you put the Jenkins file in your source code, that means your entire CD pipeline is versioned. So you kind of have CD for your CD, if you see what I mean. So every time you change your pipeline, it's a code commit, which then goes through your CD pipeline to check if it works. So if you decide to go from, I don't know, Maven 3.2 to Maven 3.3, that would be a commit change in your source code, which would then go through CD, and it would all be tested. So that's all kind of cool. So Jenkins file is the new hotness. What Fabricate does is it adds a few things on top. So there's a few different ways of doing reuse with Jenkins pipelines. So the first time you use a Jenkins pipeline, you tend to just have one Jenkins file and you put everything in there by hand. And then over time, you can refactor them. You can refactor pieces of your Jenkins file to make functions, which you can then reuse functions. For example, doing a Maven release. You want to create a new tag, you want to tag Git, you want to do the Maven build, then you want to stage it, then you want to do the Git push and all that kind of stuff. At first, you do it all by hand, right, in the Jenkins file. And over time, you think, why do we refactor this? Because I've got more than one build to do. Let's make reusable functions. So over time, you can make more and more reusable functions for your Jenkins files. What we've actually done is the next level of reuse. We have a library of pipelines. So if you remember James's demo, we chose one of the pipelines. You don't even need to write the pipelines anymore. You just pick one, and it just works. We imagine if you have, say, 200 microservices, you probably don't want to write by hand a pipeline for each one. You probably want to just use one, right? So we're expecting most people to have libraries of pipelines that you just reuse, right? Life's too short for handcrafting Jenkins files. So we have reusable functions and reusable pipelines, right? So you can just pick one, and you're good to go. So that's pipelines. So those are the big three giants that we stand on. There's a whole bunch of others too. There's way more than this, but this is just a quick example of some of the other projects we use in Fabricate. To call out a few, James demonstrated centralized logging and metrics. Centralized logging and metrics is crucial if you're doing microservices. As soon as you start doing containers, and containers can start and stop at any point in time on any machine with its own unique IP address and its own name, it's pretty hard to understand what the hell is going on, right? You can't have little sticky notes on your monitor with URLs to SSH in to look at things, right? You need to automate the collection of metrics and logging. So for the logging side of things, Elasticsearch is the back end. You can just chuck JSON in there, and it will index it, and you can search and sort and whatnot. The dashboard is called Kibana, which James demonstrated. So for logging, it's Elasticsearch and Kibana. Metrics are a different thing. Metrics isn't about storing blobs of JSON metadata. Metrics are about storing time series of numbers, like what's the CPU rate for the last year for this one container and so forth. So for metrics, we use something called Prometheus, which captures metrics from every Docker container automatically. So without doing anything, if you just run the management app, it will collect all the metrics from every Docker container, and every Java app that has JMX metrics, those all get captured too. So you get metrics captured and logs captured. And then the front end is Grafana. Slightly complicated, all these open source terms, but Grafana is the front end for metrics. Kibana is the front end for logs. So that's logging, metrics, and that kind of stuff. We saw this dashboard in the demo. That's the Kibana for events. And here's a quick flick of a quick demo of some Grafana metrics. Tracing. Now, once you start building lots of microservices and they start talking to each other, it can get quite confusing knowing what's happening. And if all of a sudden microservice A starts going slow, it takes a little while to figure out, well, why is my microservice going slow? And you need to do things called tracing so you can figure out where are the bottlenecks. If your microservice is talking to other microservices, one of those could be the problem, not your microservice. So there's a tool called Zipkin, which allows you to do fine-grained tracing between microservices. So as microservices invoke other microservices, it has little breadcrumbs, so you can see, firstly, at the top diagram, what does my microservice invoke? Like, what are the microservices it talks to? And then secondly, you can get detailed metrics of where are the hotspots, which is the microservice which is slowing things down. So that's really, really useful for diagnosing performance problems. and just trying to understand what the hell is going on. Zipkin's packaged up as an app that you can just run, and it just runs in Kubernetes, and it's lovely. Circuit breakers. Another classic thing for microservices is called a circuit breaker. In other words, if one service you're invoking goes slow or becomes unresponsive, you often want to have a circuit breaker so that it will disable using that service until it comes back. And you can have a fallback option to return, say, for example, some cached data. If your recommendation engine, for example, is down, have some cached recommendations that you'll use if that service is down. So it makes it easier to have resilient systems. There's a library called Hystrix that comes from the Netflix guys that lets you do a little annotation. You see the Hystrix command? It means you can basically do like an automated try-catch around a method. If a method fails or fails to return a value within a certain time period, the circuit breaker will flick and it will use the fallback. There's also something called a Hystrix dashboard that lets you visualize all of the circuit breakers across your environment. So you can see exactly what's happening in your system at real time, which is really nice. So that's circuit breakers. ChatOps is increasingly becoming popular and trendy. If you want to look hipster, you need to drop ChatOps in a sentence just to show your hipster chops. Increasingly, chat becomes a natural way of doing DevOps. Increasingly, teams are distributed, right? And we have lots of cloud infrastructure running. A chat room is a really simple way of having the microservices talk to the developers and the developers talk to the service. So you can literally chat to Fabricate and tell it to do builds. You can interrogate what's happening. It will tell you when pods resize and go up or down. It will tell you things when things go bad. And you can get lots of motivational squirrels, which is always useful for doing development. So that's kind of cool. Or you can improve releases as well in chat, which is really nice. Rather than having to remember that the release has been kicked off and you have to go to the console and click promote, you can just get it to talk in the chat room to approve things. Then everybody in the team can see that someone's just approved the release. So it's a kind of a nice team way of working. So ChatOps is cool. Oh, we have a Chaos Monkey. I don't think I have it on the slide. The Chaos Monkey is cool for killing pods. Chaos Monkey comes from the Netflix guys. The idea of Chaos Monkey, at least, is the idea that we should all start killing things randomly in production so that we can see that our system handles failure, right? Ideally, you'd kill things during office hours when your team is actually there at work so that if you see things fail, you can check, do things recover? Now, this might seem counterintuitive at first, but if you do it while you're all watching, you can see that your system handles failure properly. So then when it's 2 a.m. and you're all asleep, you don't have to get those calls when things don't quite recover after dying. If you're using ChatOps, you get nice motivational monkeys in the chat room whenever Chaos Monkey kills things. So you kind of it's a bonus for seeing things die. It's quite fun. OK, that's ChatOps. I'm going to briefly, almost out of time, but I'm going to briefly talk about how do you as a developer develop microservices going forward. So I'll do a quick dive through. The main things as a developer when you're trying to write microservices in this new world for containerized apps, remember it's all about speed. How do we go fast? How do we develop code so it's fast? And how do we make code work on a cloud? So the first thing is elasticity and resilience. If we write a microservice, we want it to run all the time, right? And if it dies, we want it to be restarted. So Kubernetes does that bit for us. The implementation detail in Kubernetes is something called, well, it's got two names, a replication controller, or the new name is called a replica set. But basically, it's a blob of YAML, right? It's a blob of YAML where you define what you want. You define the Docker image name. You define how many replicas you wish to use. So this example is Elasticsearch. We're going to run a certain version of Elasticsearch. We're going to define some environment variables and ports and yada, yada, yada. We're going to add some labels to this replication controller so we can easily find it by querying labels. And we're saying how many to run, in this case, 1. Then Kubernetes will take care of that and make sure there's always 1 running. So if you want your thing to be highly available, just use a replication controller. In production, you should probably always run at least 2 of everything, just because if your microservice dies, Kubernetes will spin up another one. But if most microservices can take a little while just to get ready and warm up, for example. Like a Java app might take a minute to warm up and get going and feel ready to serve traffic. So if you only have 1 thing running, when that thing dies, it might be a minute before you're able to serve traffic again. So if you always run, say, 2, there's a reasonable chance that if 1 dies, there's already another one that could be serving traffic while the new guy starts up, right? But if you've got plenty of money, run 100, right? Run as many as you need if your boss has a big enough credit card. Service discovery and load balancing. So Once you have all of these different microservices, they all need to usually talk to each other in some way. And if each one of these microservices is starting and stopping randomly and scaling up and scaling down automatically and stuff, how do we discover all these things and talk to them? So Kubernetes has a thing called service discovery, which is how you can discover services in Kubernetes. This is kind of how it works. You define a service. I know that's a really overused term, but in Kubernetes, you define something called a service, which again is a blob of YAML. And the service is really just a way of grouping containers together using labels. So we're using these label selectors. You see the bottom, the selector? We're using key value pairs to find the containers we want to talk to. And then we define which target port inside the container we wish to talk to. So in this case, we're going to talk to the target point of 9200, which seems to be the default Elasticsearch port. I don't know why, but it is. And we expose it on port 80. What this metadata does is it defines a logical service. In this case, its name is Elasticsearch. Now, to talk to Elasticsearch, we just use the URL Elasticsearch. In other words, we use Elasticsearch as a host name or a DNS name. What Kubernetes does under the covers is when you talk to that DNS name gets resolved to a static IP address. Now, if ever you've heard of DNS, a lot of people always bitch about DNS and caching and issues about caching with DNS. Services in Kubernetes use a fixed IP address for the entire lifetime of the service, so there's never any issue with DNS caching, right? Each service gets its own unique IP address. So your code then talks to that IP address. Under the covers, Kubernetes then load balances that service IP address to the individual physical IP addresses of the pods. So you get automatic, simple, easy discovery and load balancing for free with Kubernetes, which is really, really awesome. Here's a little slide with a bit more detail. So if you have a service called foo-bar, if you want to talk to it over, say, REST, you just use http://foo.bar, or HTTPS if you're using HTTPS. So you literally just use the DNS name of the service. Now, I haven't talked about it yet, but there's something called namespaces in Kubernetes. And namespaces is a way of having logical clusters. So you might have a physical cluster of Kubernetes, and you want to logically split it into, for example, development, testing, and production, say. One of the lovely things about service discovery in Kubernetes is the service discovery works within the namespace. So you don't accidentally talk to the production database if you're in testing, or if you're in development, you don't talk to the production database, right? So each namespace is completely separate from a service discovery perspective. Now, what we've often spent a lot of our time doing is putting dollar squigglies everywhere in our app so that we can write an app once and it will talk to a database, and you have dollar squigglies that you search and replace to find out where the development database is and the production database and the system test database and so forth. Service discovery in Kubernetes fixes all of that. You can literally hard code the URLs for everything, and when it deploys in each environment, you just find the resources, the services for your environment, which is really, really nice. So that's service discovery. One other thing I haven't mentioned, so sometimes not everything is running inside Kubernetes. For example, you might be talking to a service which is implemented by a software as a service vendor, right? Or you might have a database that's hosted outside of Kubernetes because another team hosts the databases on OpenStack or something, right? So with Kubernetes services, normally you use a selector to find the pods to talk to. You can also implement the service by using endpoints. In other words, you can specify where the service lives outside of Kubernetes, and it links to it. So you can use the same service discovery and load balancing, even though the service is outside of Kubernetes. Right? So services can be implemented inside Kubernetes, or they can be implemented outside. So if you're a Java person, think of services as a, okay, get ready. Think of Java as services as a bit like dependency injection, but for services. Right? It's a way of dynamically wiring where the service is, but it works in any language, right? This works for Node, this works for Go, this works for Ruby, this works for Rails. It works for any language, right? So it's kind of like polyglot dependency injection for service discovery, right? It's really, really awesome. Now, normally, services are only inside Kubernetes, right? So normally, when you create all these services, only things running in the cluster can see things. So your browser, for example, can't normally see services out of the box. So there's a way of also exposing or exporting services outside of Kubernetes. There's a command line, kubectl export, that exports things. There's a few different options here, depending on if you're using OpenShift or if you're using Kubernetes. If you're using Kubernetes, you use something called an ingress to do external load balancers. OpenShift has something called routes, or routes, depending on how you pronounce it. And then on Google Container Engine, it's got its own load balancer as well. In each case, it's just a blob of metadata, really, that you define what URL do you talk to from outside Kubernetes that then loads balance to the service inside Kubernetes. So that's Kubernetes services. So that's basically how you do service discovery and load balancing for anything in Kubernetes, which is awesome. We talked about logging and metrics already. The only thing I'll just say about logging is the best thing to do in your microservice is output to standard out. It's tradition, especially with Java folks, to have like rolling log appenders and all this kind of malarkey. Like, stop all that. Like, that's so 90s. These days, standard out is the new hotness. I know we started like that and then we went away from it. Now it's back again. Okay, so standard out is now cool. Okay, but the other thing that's even cooler is write JSON to standard out. That's even cooler. Now that might sound weird, but if you write JSON, that means that JSON can be automatically parsed and indexed by Elasticsearch. If you just write a stream of text, it's quite hard to know automatically what's the thread, what's the class name, what's the line number, what's info or warn or log or whatever. If you use JSON, it's automatic, so then you get really nice automatic context in your logs when you search. So please use JSON, but definitely use standard out. Anything that's written to standard out gets automatically captured and put in Elasticsearch. So please use standard out. For metrics, all of the projects you create through the Fabricate console all use the same, if they're Java, they all use the same base images, which all have Prometheus in there and a Prometheus endpoint to export metrics. So any JMX metrics get captured by default. So if you're writing a Java app and you want to expose some business level metrics, just try and either write your own Prometheus endpoint or try use JMX to expose the metrics, and then those will get captured automatically as well. So standard out, JSON, and JMX for metrics. Almost out of time. Hystrix is a Java library you can add to your Java code for doing circuit breakers. Apache Camel in 2.18 has circuit breakers built in by default as well. And then Zipkin's another library you can add into your project to do tracing. We're hoping over time to make most of these things invisible using something called a sidecar, which means what we really want to do is add all these features like logging and metrics and tracing and stuff automatically to all apps without you having to change your code. So ideally, you won't have to do anything and you get all this stuff for free. But right now, today, you have to add Hystrix yourself by hand or Zipkin. But we're hoping to do it via sidecars so that we can implicitly add a separate container next to your container that does all the Zipkin tracing for you. So that's the ideal, and we'll be there soon, I hope. Configuration. Now, a common question people have is, so how do I configure my app so that I might want to configure things differently in production from testing and so on and so forth? Now, the first thing I'd say is we want to go faster, right? We want to automate everything, and we want to minimize the chances of making a mistake. So what we really want to do is try to put everything in the Docker image so it's immutable. Now, in the old days, in the Java days, we used to make jars and wars and stuff like that, and we'd release a war to production, and then somebody in production would take that war and figure out how to put it into some app server, which was okay. At least the war didn't change between development, testing, and production. But the slight issue is production app servers were independent of your release cycle. So who knows what version of the app server is in production, and is it the same version of the app server that was in testing? And normally the mistakes are someone else is configuring the app server independently from your war, and all sorts of trouble normally ensures. So the better way of doing that is rather than releasing a war, is you release the Docker image with the app server inside it with all of the configuration there. But the next issue is what happens if you want to reconfigure something in production that's different to testing. Now, do you remember the bit about the service discovery? Service discovery means you don't really have to reconfigure things for service discovery anymore. That should be the same. So the only real missing piece, mostly missing piece, is how do you configure the login and passwords and the SSH keys and all that kind of authentication security stuff. Now, Kubernetes comes with something called secrets, which means in each environment, you can install or generate secrets like login and passwords, GPG, SSH keys, certificates, all of that lovely, horrible security stuff. You can generate that in each environment, and those get mounted into your container on the file system. You can either expose them as environment variables, which is okay, not very secure, but it's okay, but the files are kind of better. So, for example, you can put your SSH key as a file on the disk. So rather than putting login and passwords in your Docker container, which is a really bad idea, you keep them out of your Docker container, you put the secrets in the environment, and then your app doesn't need to configure things explicitly. It can just expose secrets to your app. So with service discovery and secrets, there shouldn't be really that much left that you need to actually configure in different environments. I'd even try and recommend, try not to have per environment configuration other than service discovery and secrets. Just because it means then you have an immutable app that you're testing everything, and that one thing goes through testing, production, UAT, load testing, soak testing, and production. The less you change in production, the more real your system test is, right? And the less chance of breakage. If you still really want to change something in production that's different to testing, which you've got to really think carefully about doing this, but if you really do want to do it, you've got two options. Config maps is another resource in Kubernetes that lets you chuck key value pairs or config files and stuff into, and then those can be exposed either as environment variables or as files. For example, if you use Spring Boot, the Spring Boot application properties file can be stored in a config map and then can be mounted onto the disk in a /config folder, so then your Spring code will pick up whatever properties there are. So if you want to tweak like a couple of properties, pop them in an application properties file in a config map, and you can then edit them in each environment if you wish. But remember, you might break things. The other option is something called a Git repo volume. So Kubernetes has a whole lot of different plugins for file systems. One of them is a Git repo. So you can take any Git repository and any tag or SHA in that Git repository and mount it as a folder or a volume inside your container. So you can put all of your config files in Git and then use the Git repo to put them on disk for your container. So the good thing about Git is it's versioned. The downside is you need a Git repo. The good thing about config map is it's already included out of the box, but there's no versioning. There's just the latest version, right? So depending on if you want versioning or not, if you want versioning, use Git. So that's configuration. Almost done. Testing. So we all need unit tests, which is fine, but after that, all of your testing should be done in Kubernetes with Docker, right? There's no point testing on your Mac or your Windows machine, because that's not what production will be, right? You want to be testing in a production-like environment all the time. It's a waste of our time to test anywhere else, right? So we need to get in the habit of doing system testing and load testing and soak testing inside pods, inside Docker containers in Kubernetes, right? Here's a little example of what it looks simple, but this is a really good system test. Fabricate comes with a system testing library called Fabricate-Ing, which is a plugin for something called Ing that lets you run unit tests, but using in-container testing. Now, Ing was based around testing apps inside app servers like JBoss and things. What we've done is extend Ing to work with Kubernetes. So what this does is, when you run this test, it spins up a new namespace in Kubernetes, deploys all the Kubernetes resources into that namespace, asserts that everything starts up correctly, then it runs your test. And this test asserts that all of the deployment pods start up, become ready, and stay ready for a period of time. I think the default's like 10 seconds. Now, that might seem a trivial test, but what happens under the covers? OK, let me step back a bit. If you're using Spring Boot, the Maven tooling from Fabricate automatically detects you've got Spring Boot there, and Spring Boot has a health check endpoint. Kubernetes has a health check capability baked in, so we add the health check to automatically check the health of your containers. So if ever your app goes bad, like it can't connect to the database, or it can't start some camera routes, or whatever, right? Those health checks will fail. Kubernetes will see that that's failed, and it will restart your containers automatically for you, which is cool. So what this system test does is this asserts that all of the health checks pass so that your containers become ready, and they stay ready for 10 seconds. Now, what usually happens is when you make a mistake, like, I don't know, use the wrong command, or use the wrong main in your Java main, or you set the wrong environment variable, or you make a typo, or you talk to the wrong service, or whatever it is, right? Any kind of mistake will mean that the JVM will fail, or the process will fail. This test asserts that everything starts up and keeps running and stays healthy, right, in one line of code, nice and simple. Now, you can obviously do more testing than this. You can then interact with your application and assert that, it processes messages correctly or whatever. But the interesting thing is just using health checks in Kubernetes means we can write really good system tests, because we're using the same health checks that we want to use in production for testing. Right, I'm totally over time now. Oh, we're done. Brilliant. Awesome. So there we go. So Fabricate microservices platform is a way of using Docker containers, Kubernetes, and Jenkins pipelines to create microservices, build them, test them, approve them, and run them and operate them at scale. It's increasingly all about speed. We need to go faster. We need to iterate faster. So please give it a go. There's the URL on the slide, fabricate.io. Click the Getting Started. There's a whole bunch of different videos and demos and whatnot. And let us know any feedback you've got. Any questions? We don't really have any time, but any questions? Was that all totally obvious? And so, yes? You need to run Kubernetes or OpenShift, yes. Yeah. All that has to be. So we've already got Docker images for Elasticsearch and Kibana, so you don't have to build those. You can just run those. Do you remember the section on service discovery? That's how everything discovers everything, right? So that's how it's slightly more complicated than that, but because Elasticsearch, you need to discover all the peers because it does sharding. But the basic trick is DNS. You can either use DNS or the REST API to find all of the pods. So if you want, you could use the REST API and Kubernetes to find all the other instances and wire it up that way, but yes. So service discovery. So the Docker image we ship has pre-baked discovery inside, so it knows it's going to run in Kubernetes and it's going to discover itself through DNS. So you just run it, scale up how many pods you want, and it just all works. Yeah. Any other questions? I'm going to get kicked out soon, I think. Well, thank you very much. Have a good conference.